Hello everyone, in this video we're going to implement three functions. So the first function is a step sample function or delta function, which is 1 at 0, and at the rest is 0. Say 1, 2, 3, these are 0, and so on. And at the negative side is 0, 2, negative 1, negative 2, negative 3, 0. So this is a delta function. Delta function or unit sample. Sample sequence. And the second signal is going to be unit step function. So unit step function is 1 at 0, 1, 2, 3, 4, and so on. And it's negative at negative 0, negative 2, negative 3, and so on. And the third one, so this, let's see, this is a unit step sequence. And the third signal is a random signal. I just come up with a signal to show how you can implement a signal on Matlab. Let's say, I don't know, it's just probably 2. So 0, 1, 2, 3. Here is at 0, here is at 3, and here is 1, and here we have 1, and let's say this is a 2, and negative 1, negative 2. Right. So let's see how we can implement these three signals in Matlab. Alright, so I open the Matlab software, and I open a new script file, and I start writing the code here. So normally I write on the top of my file, close all, clear all, and CLC to make sure not any file or any variables execute beside the scope of this file. Alright, so let's start with the unit sample sequence or delta function. Delta function or unit sample sequence. Alright. Okay, so let's see how we can accomplish this. So first I start with the range. So n equals to, let's see, between negative 3 and 3, and x equals to, let's say, n equals to 0, and I'll use the subplot 3, 1, 1, and I'll use a stem function, and n equals to x. So this line of code is comparing each sequence to 0, and when it's comparing, it give us, let's say for example it says let me show you what is exactly doing this line of code. Basically says negative 3, is it equal to 0? No, it's not. So give us a 0. And negative 2 is equals to 0? No, it's 0. And until 0 equals to 0, yes, it is. So give us 1, and the rest are sort of 0. So, and it's so we have a signal of everywhere is 0 except at 0, which is 1. So now if I execute the code with plotting, and you see how it look like. As you see, negative 3 to 3 range, and 1 is it's at 0 is 1. Alright, so let's do the second signal. So the second signal is unit step sequence, and for this signal I'll the variable n1 is the range. Let's say negative 4 and 4, and x1 equals to n1 greater than or equals to 0, and subplot 3, 1, 2, and I use stem function, and n1 and x1 is the parameters. Alright, so when I run the code, you see that the second signal is a unit step function. It's the negative side is 0, and at the positive end 0 is 1. Alright, so let's see the last one. The last one is a let's say random sequence. Let's see, the range is between, let's say, negative 5 and 5, and let's see, x equals to 2, 1, 0, 5, let's see, 3, 1, 2, 3, 4, 3, and let's see, so 5 to 5 is 10 and plus 1, so we have to have a 11 samples. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, so let's see how we can subplot, how we can plot this signal too. Using subplot 3, 1, 3, and I'll use the stem function again, and let's see, also this should be n2, and this is the x2, n2 and x2. Alright, so let's see how it look like. Alright, as you see, let's see, run it again. Alright, as you see, the last signal is the range is between negative 5 and 5, and the all values of x2 is shown on this plot. I think we accomplished this writing code for these 3 signals, and that's it for this video. Thank you for watching.